Alright guys, today we are talking about systems of linear equations. And so the first few bullet points here are just giving you some information on what systems of linear equations are. And to start out, like the activity we did in class where we had multiple graphs, a system of linear equations is a set of two or more linear equations considered together. So if we graph two equations, that is a system. If we were to graph these two equations, that would be a system of equations. Let me focus this. Alright, a solution to a system of linear equations is an ordered pair. And that makes every equation in that system true. So, a solution to this system would be the x and y value that is true for both of those equations. A linear system can have one, no, or infinite solutions. If the system of linear equations has one solution, the lines intersect. So again, referring back to our activity, if you picked the graph or looked at a graph where the lines were intersecting, that was one solution. If the equation's linear system has no solutions, then the lines are parallel. As you know, parallel lines never intersect, so there is no solution. Parallel lines also have the same slope, which y'all did marvelously on. And if the system of linear equations has infinite solutions, the lines are the same. So they have the same slope and y-intercept. Now, with infinite solutions, or these are also called coinciding lines, the equations may be written in different forms but equal the same thing. For instance, if I have y equals 3x plus 4, if I write this in standard form, it'd be negative 3x plus y equals 4. You have to be able to either get the first equation in the standard form to see it looks like the second, or solve for y to see that it looks like the first. Either way, you need to know or understand that those two are the same, and there'll be infinite many solutions because they're the same line. Alright, so the first example, or the first graph here, is one solution because it intersects at one place. And then the second, since these lines are parallel, no solution. No solution, yeah. Those they have the same slope. And when you're looking at a graph and there's infinite solutions, it's going to look like one line because the lines lay on top of each other. The lines are on top of each other. Oh yeah. So it looks like one line. So, solving by graphing. So there's three ways we solve systems of equations. There is by graphing, by the substitution method, and by the elimination method. Today, in these notes, we're just going to look specifically at graphing. So you can graph by, and that's a graphical representation. That can be by a graph, or as we'll see momentarily, looking at a table, which is also a graphic. All right, so if we are given two equations, we first have to graph each one of them. So remember, to graph an equation, start at the y-intercept. So this y-intercept here is -1. So that's b, and our slope is 3. So we're going to go up 3 over 1. That's kind of close, so let's go up 3 and over 1 again. Now you may want to get a ruler, or I'll just use my ID, like I tell y'all in class, to draw a straight line. Bloop, bloop. So that's that one, and I'm going to use another color for the second. So again, start the y-intercept. 1, 2, 3, 4. And go down to, since it's negative, over 1. Down to over 1. And then again, draw this straight line. So once you have those lines drawn, let's zoom in. Dum, dum, dum. You look at where they intersect. And we see they have a point of intersection right here. All right, and so that point is 1, 2. And it's easy as that. Now, I will also show you how to do it in our calculator, if I remember. What time is it? Please excuse the bell in a moment. When your equations are in y equals, you can go to y equals and graph those two equations. So you press the y equals button here. And our first equation is y equals 3x minus 1. Do not use the multiplication symbol for x. Like on big ideas, when we accidentally use x, you don't use that. This is the variable x up here. So we press 3x minus 1 and negative 2x. Let me zoom out because it's making me mad. So this is negative down here. Negative 2x plus 4. Alright, once you have those two equations in, you hit graph. And that looks strikingly similar to our graph. And so to find the point of intersection, you're going to press trace. I lied. Second trace. So the blue button and trace. And we are looking for the intersection, which is 5. And then it's going to ask you some questions. The first is first curve. So it's asking which lines are we looking for in intersection. So we press enter. It should jump to the other line. Press enter. And it's going to say yes. You just press enter again. And you get the 0.12 like we just did. Real easy, real easy. As long as it's in y equal. Now, you can get any equation into y equals, but that will require you understanding how to solve for a variable. So, next example. Start at 1. Go up 3 over 4. And connect those. And then the other line, now remember this is a 1 in front of this x here. Start at -6. 1, 2, 3, 4, 5, 6. Go down 1 over 1. Down 1 over 1. Down 1 over 1. Alright, and again, where the two lines cross is our point of intersection, which is 1, 2, 3, 4, negative 4, 2. I was about to ask if there are any questions, but y'all ain't supposed to be talking right now. You are correct, my bad. Negative 4, negative 2. If you're wondering who I'm talking to, I actually have a class in here right now. Alright, then we can graph it also. Alpha y equals, for this fraction here, 3 over 4 x plus 1 and negative x minus 6. And graph it, again, looks real similar to ours. Second, trace, intersect, enter. Boom, negative 4, negative 2. We smart. They're giving me the thumbs down right now. Alright, so we know a table can represent a graph also. And since the solution of a system of equations is where the graphs intersect, that point must be on both lines. When finding a solution from a table, look for the ordered pair that is on both tables. Alright, so if I'm looking at these two tables, between them, I see that this point is on this one and on this one. So my solution is negative 2, 6. So I'm going to come down to these bottom ones real quick, and then we're going to come back to this middle section. Looking between two tables, I see 2, 7 is on both of them. So that's my solution there. And now some tables, you'll have x listed, and then y1 and y2. Alright, on some graphs, you'll be given the x value, and this is one equation, and this is another equation. You have two different y outcomes. So you just look at where the y's are the same, and our solution is 7, 17 right here. Come over these two tables. 1 and 0. We should know that is a x-intercept since our y is 0. And then the last one, 0, 15, which is a y-intercept since our x is 0. Now we'll go back to this example. If you don't find a common point, you can just plot all the points, draw the line through them, and then see where they intersect. And then furthermore, you don't even have to plot all the points, because since we know these are our points on a line, we can just pick a couple and draw a line through those 2 points. So I can do negative 2, negative 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 3, 5, for instance. 1, 2, 3, 1, 2, 3, 4, 5. And then draw a line through those 2 points. Now, if it helps you to draw a more accurate line to plot all the points, then do so. And then from the other graph, we have negative 2, 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And 4, negative 10. 1, 2, 3, 4. Alright, and we see that our point of intersection is 1, -1. Alright, another way you can do it, you can find the equation of each table, put it in y equals, find where it intersects. There's a myriad of ways you can find this point of intersection, which you should also know that's what a solution is called, a point of intersection. Alright, so we also have a couple of special solutions. One was the no solution one, when the lines are parallel. So when the lines are parallel, you won't have a solution because there is no point of intersection. They never cross each other. So as we see, if I plot this first graph, start at 1, goes down 1 over 1 because our slope is -1. And I'll plot that line. And do the same thing for the other. Alright, those two lines will never cross. Alright, same for the second. Start at -2. Go up 3 over 1. Start at 0. Never cross. Now, without graphing these, I should be able to look at those set of equations and just look at the slope and tell if there's no solution or not. So if the slopes are the same, we know that makes the lines parallel, therefore there will be no solution. So I didn't even have to graph these two lines to know that there was no solution. Just look at the slope, see if they're parallel or not. And then the last one, where you have infinitely many solutions or infinite solutions. So we were to get both of these equations into y equals. I see that both of my equations are the same. This is what I was talking about. If you have to make sure you solve it into one form or the other. Or I could have just went here, divided everything by 2, and saw that it was the same equation. But the easiest way, get into slope-intercept form. That way you can see that they are in fact the same equation. And you really only have to graph one line, because they lay on top of each other. And that, my friends, is the end.